All right, so hello once again. This is a continuation of our the first video that I created for VMware, and there we talked about distributed networking, right? I have showed you how to configure or to create a logical switch, and how to configure the DLR so that it's going to be able to connect to a logical switch. So an endpoint from one logical switch can talk to another endpoint on another logical switch. So as I've said, it's just like router on a stick, right? It's actually very easy when you try it in the lab. All right. So now let's gonna explore the second module, okay, which is gonna be talking about edge services. So here we have the NSX Edge Services Gateway, or ESG, which is a VM form factor appliance that provides routing and other advanced network services like load balancing, NAT, VPN, and etc. In this module, we're going to explore some of the features of ESG and deploy those capabilities in the lab environment. All right. I don't have any idea what this is. All right, we're gonna try. I know what an NSX Edge is, but let's see. I know what the load balancer is, not VPN, but I haven't seen it in action inside the vSphere environment. So but here we're gonna do that, right? We're gonna try that. Okay. So let's go to the Edge services. There's a lot of features here. Edge dynamic routing. Okay. Edge dynamic routing distributed logical router. Edge services gateway. Gateway routing verification. Configure edge services. Okay. A lot of tasks. But let's give it a try. Okay. So as we learned in module one, all right, in this module, we'll learn how the NSX Edge Service Gateway, or ESG, provides network edge security and routing services into and out of the virtualized environment. The ESG has a number of options for passing north-south traffic in scalable and resilient manner. So what's north-south, right? So there's actually east-west and north-south. So when you say north-south traffic, so you have if you have like a, how do we say it? So if you have like a data center, right? So you have a firewall in here, and this is a switch. You have an endpoint in here, and you have another switch on top, and you have another endpoint, right? So when we talk about north-south traffic, the traffic will be coming from here and going to there via the firewall. That's north-south traffic, and it's surely it's going to be on a different network or a different segment that we're talking to, right? Because this guy has to, forward it to the firewall first. And definitely firewall will break that down unless it's on transparent mode. But if it's a routed mode firewall, then this is north-south traffic, right? There's also another term called east-west traffic. So east-west traffic, let's say, well, coming from here, going to that is east-west, right? If you have like another switch here on the same fabric, you have an endpoint, and this talk to each other, that is also east-west, right? Because you're on the same fabric. So that's the difference. All right. So be very familiar with that when you deal with data center networks. So that's how we normally talk, right, in terms of the workflow. Is it north-south traffic or east-west traffic? All right. So in addition to its routing capabilities, the NSX Edge Services Gateway also offers many advanced gateway services. This includes DHCP, which I'm sure you already know, VPN, virtual private networks, NAT, network address translation, and load balancing, and a traditional layer 3 firewall. Leveraging these capabilities is done by simply enabling them with the ESG's configuration. Now, we'll use this module to explore some of these services offered by ESG. By the end of this module, you're going to have an opportunity to do all of this. All right, so let's distribute it, blah, blah. All right. If you skip module one, let's skip the next slide. Oh, okay. There's a script, right? If you want to go straight, but since we did, I actually did module one, so I don't have to run the script. Okay, so the first one is we're gonna do dynamic routing on the distributed logical router. So let's see how it works. I would think that, okay, I would think that if you have a router in here, then you have like connection to the logical switch, right? And you put the IP addresses in here. So dynamic routing is that if this is an L3 peer, all of the new subnets in here, you're going to advertise it back there to the L3 peer. That's what I think. That's just a hunch, but that's what I understand, right? So if there's a new subnet configured here, remember, right, when we did the DLR lab, we add an IP address there. So that will be automatically advertised to the layer 3 peer, right? If there's an L3 peering. So I don't know, let's try that. So go to here and network and security. On the left side, select NSX Edge. Okay, NSX Edge, where the DLRs are. This one, right? DLR. Once the NSX edges are, oh, no. So an NSX edge, okay, it's time corrected. So an NSX edge, it seems that it could be a distributed logical router. It's clear, and it could be an edge services gateway. I don't know what that means yet. Maybe like for this one, maybe it's a load balancer. I don't know yet, but we can verify later. Okay. So on the left-hand side, NSX Edge, let's look at Edge 6. So click on that. What can we see? So go to where? Routing, global config, dynamic routing configuration. Right now, you can see OSPF and BGP. It's stopped. Why? There's no EIGRP. Well, maybe VMware doesn't support EIGRP yet because, well, from history, right, we know EIGRP is a routing protocol that only works for with Cisco. But right now, I heard there are some vendors who are able to run EIGRP as well, but not VMware, right? But we have OSPF, that's fine, right? I don't think we're gonna run a lot of complicated routing, complicated layered 3 networks. For us to have like some flexibility on deploying the other routing protocols like ISIS and EIGRP. So I think this one, OSPF, BGP, that should be enough. That's what I think. That's why they just put this two routing protocols as being supported in NSX Edge. So we go to edit. Edit dynamic routing configuration, router ID. Okay, yeah, it should have a router ID. Right, so if you remember, right, OSPF, when you do OSPF and BGP, this is very important, right? It's best to have a router ID. If you don't configure it, it's gonna assign one, right? I don't know for VMware, but on the Cisco router, it will do. So let's see it. Router ID denotes IP address in the lab scenario. We're using a router ID that's the same as the IP address of the uplink interface on the NSX Edge. The screen will return the global config session with the option to publish changes. Now confirm that the router ID field displays the IP address associated to the DC transit logical switch 172.16.0.10. Okay. The configuration change did not apply successfully. Remain blank. Okay, blah blah. And let's save. All right, so there you go. So it's just like in iOS XR 18.0 Cisco. Once you do a change, you have to commit it, right? On this one, you have to publish it, right? So publish. There you go. Go to summary. Oh no, go to routing. Okay, the job is completed as we see, right? Go to BGP. Then click edit. So here we're going to use BGP as our dynamic routing protocol between DC Edge 01 and DLR 01. This will allow the two routers to exchange information about their known routes. Okay, yep, that's it, right? So you have like a DC Edge 1 here, you have a DLR in here, DLR. This is edge. So you have a routing protocol running. Maybe we're going to use BGP. So whatever networks that you have at the back of this guy will be advertised to the DLR, and DLR can also advertise it back. So we have end-to-end reachability, right? End-to-end reachability. That's what it means. Okay. So once we click BGP, then click edit, and this will open the edit BGP configuration dialog box. Okay, then click on the toggle button next to the status. Okay, we have to enable it. It has to be green. In the local AS, of course, if you're running BGP, you need to have an AS or autonomous system number. So the screen will return the BGP config once you save it. Let's see. Then, okay, then publish change. All right, so in the networking world, we just we do a router BGP, then you put the AS number 65001. That's what we do. So we enabled BGP on this edge, on this DLR, sorry, DLR01. Oh, however, please do not publish yet. I published it already. Anyway. I published it. That's fine. Let's see what happens, right? It seems that we're gonna add the neighbor here. Yep, to add the BGP neighbor. In this example, we add DC Edge 01 as the BGP neighbor of DLR 01. Okay. So the interface, DC transit, okay, it's there already. Then we add the IP address of the peer 172.16, 172.16.01. Protocol address, what does that mean? IP address of the BGP neighbor. What is the forwarding? So the forwarding, this is the data plane interface of DLR01 connected to the DC trans. Yeah, this is the this is the it says the data plane interface. What does that mean? Maybe the underlay IP address. I don't know. So 172.16.0.11 and the remote AS of the other router, which remote AS. Oh, okay, so 65.0.1. So it seems they're using the same AS, so this is just IBGP, right? So they have the same AS. So the forwarding address is the IP address that you assign to the distributed logical router interface, facing its BGP neighbor, its uplink interface. Protocol address, the IP address that the logical router uses to form a BGP neighbor relationship. Okay. It can be any IP address in the same subnet as the forwarding address. Okay. But this IP address must not be used anywhere else. But when you configure BGP peering between the edge services gateway and the logical router, use the protocol IP address of the logical router as the BGP neighbor, okay, of the ESG, this one. Okay. So the weight, yeah, so common rate for BGP, all of these attributes or parameters should match. Otherwise, your BGP peering is not going to go up, including the password if you have password. Okay. All right. We need to use the scroll bar to return and publish. Okay. Yeah, I don't see any reason why it shouldn't work, even though we enabled BGP and publish it. And here we just added some more lines or config to configure the peer. Okay. So right now it shows started. Yep, it is. It matches. So this is just from the DLR going to the other edge switch. Okay, so enable route redistribution. Okay, so we enable route redistribution if we have a particular network that we want to let the other routing protocol know. Right, so let's see how we do it. So route redistribution. enable BGP, but OSPF should be disabled. Okay. So no redistribution to OSPF, just BGP. Click on the toggle button next to the BGP, right? Under the, click add. Then click any, the learner protocol is BGP. So coming from another network, we're gonna redistribute it to BGP. But in this case, it's just gonna be connected to route, right? Because this DLR has its own IP addresses, right? Remember on the router on a stick, we have sub interfaces there. Those are considered as connected routes. And this will, all of these connected routes are going to be distributed to the learner protocol, which is BGP. Okay, then the action is permit add. All right, then let's publish. Okay. Now we're going to configure the dynamic routing protocol on the neighbor, which is the edge services gateway. So we have pre-configured or configured the DLR. Now we're going to do it on the ESG. So navigate, so click back, and so we can get the other routers. And click Edge 5. So that's the Edge Service Gateway. Okay. So when you click on Edge Service Gateway, you have all of this function, which is great, right? It can be a firewall, can provide DHCP, DNS service, NAT routing, load balancer, VPN, and so on. So go to routing, global config, edit. Okay, there's a router ID already. Save. Okay, or publish. And go to BGP. Right, so the BGP neighbor is not yet up because we haven't configured the DC edge, the other ESG or the edge services gateway. We just did it on the DLR. So we click edit, then edit. Next, click edit the change configuration. Yep, enable it. Graceful restart, right? That's a good practice to have graceful restart. So enable disables the ability to preserve forwarding state during restart of the BGP process. Default originate. Well, in network, you use it. If you have a default route learned by this router and you want it to be redistributed to a particular neighbor routing protocol, right? So if you have a default route, you want it to be advertised down. So you use the default originate option. Then local AS, it's 65,001. Save. Okay, so well, we're not gonna publish it yet because we need to add more parameters such as the neighbor. Let's just follow the lab 172. It's 172.16.0.11 and AS number 6501, and keep just set. This is the default. Even in Cisco routers, I think this is the default. We'll just leave it as it is and click add. Once there, we add another one. Okay, it's this one, 192.168.100.1 remote AS. So another AS 6502. Okay, remote private AS. Oh, have to disable it. Remove private AS, so the wait. Okay. And all right, so this is started, default originate, stop, we don't need it. Local AS 65,001. Then we go ahead and publish it. Awesome. All right, so how do we verify it, right? So in this section, we're going to look at various elements to see how routing is configured northbound from the NSX ESG. Okay, so that's the reference. So you have the ESG in here, right? And you have a DLR, I think. Is it? No, I actually don't know. Well, let's see. Configure northbound from the NSX edge. This includes how dynamic routing is controlled, updated, and propagated throughout the NSX environment. We'll still verify that routes are exchanged between the NSX DC Edge appliance and the virtual router appliance, which runs the routes the entire life. Okay, so let's expand this and try to interpret the diagram. So earlier we created this, right? So all of the logical switches, this has an IP address already on the DLR. So the servers are here below the DLR, and you have a connection going to the ESG via the DC transit. So this is a IBGP session, right? Internal BGP, because they're using the same AS. And remember from the ESG, we configured another AS or another peering via, we don't know where it is, but it's using a different AS number, which is 65,002. So according to this one, this is a VPod router. Right? Maybe it's not part of the environment, of the NSX environment. It's just another router outside the NSX environment. Okay. So let's move on. So first confirm the web portal is functional. Web app is functional. Then we will log into the DC ESG to view the BGP neighbors and see existing route information. And this will show how the DC Edge on ESG is learning routes from not only from the DLR, but also from the VPod router. That's cool, right? So what we're trying to verify here, since we have a peering between, so all of the subnets here will be known from the ESG, and also the routes here will be advertised here. So this guy should know all of these routes here and here. So let's double check that. Okay, first we confirm the web app is functional, blah, blah, okay. Customer DB app. Okay, so let's verify the 3-tier is working, yep. The 3 tiers, logical switches, and NSG. 3 tiers of the application are on the logic, right, on the bottom, right, at the bottom. The NSX distributed routing is providing routing between these tiers. The DLR, the ESG is providing us north-south routing to reach the web application from the main console. So I guess this is the web application. All right. So we go to the VMs and templates. Then look at DC Edge 01 plus 1. Then we launch the console. Let's use the web console. All right. So now we're on the DC Edge ESG. Log in. Is there a login? Oh, there you go. It's just a delay. Admin VMware 1. VMware 1. Okay, we're logged into the ESG. Oh, okay. I notice it's quite long because it's a requirement, right? You need a 12-character complex password for the ESG to work. Okay, show the same Cisco, the same command from Cisco. Okay, makes sense. So IP. I wonder if it's gonna show the same output from Cisco. Let's see. I'm gonna laugh if it's the same. Oh no, no. Okay, so it says no BGP peer configured. So in case you do not see any BGP neighbors, go back to vCenter to verify which node is active. Okay. I thought we did something wrong, but it seems it's okay. NSX network security. Then click on NSX Edge and click on DC Edge 01. Click on the status. What's wrong? So DC Edge 0101 for standby seems the same. Okay. So this guy is a standby DC Edge. That's why it doesn't show us the BGP peer. I understand. Okay, so we have to log into this guy, right? Because this is the active ESG. So we should be able to go there. So let's see. VMs and templates. This is the pair, the other one, right? So this is the one that we logged into, but it doesn't show the peer because it's a standby router. So the active one is 0101. So let's go to launch web console. Okay, of course we have to log in again. Okay, admin. Oops. Admin. VMware 1. VMware 1. All right. Okay, here it is. Show IP BGP neighbors. Well, it looks the same. Let's see if they have a show IP BGP summary. They don't. Yeah, but show IP BGP neighbor looks the same, I think. With Cisco. Maybe the guy who developed this is from Cisco. I don't know. So, yep. You see here the BGP neighbor. BGP neighbor IP. It's up. The default timers is there. Okay, 12 messages, 12 sent. So it means that they were able to negotiate to be able to establish the BGP neighbor. So this is the first neighbor. And this is the second neighbor, right? Going to the virtual pod router, I would say, because it has a different AS and the BGP state is up. Okay, so both states are up, going to the VPod router on top, then on going to the DLR on at the bottom of the network. Awesome, right? So this works. Oh yeah, so yep, that's what we discussed, right? So this is just based on the observation, and just so happened that okay, the next page has that. Cool. So this means I still remember my BGP class because it almost looks the same. Oh, there's also another command, show IP route. Let's see. It looks almost the same as Cisco, but it's fine. Yeah. I imagine it's gonna be if it's a different view, then you have some you need to you're gonna require some learning curve. But since this is almost the same as Cisco, then all good, right? So it's showing us, so let's interpret the routing table. So you have a default route here, and you learn it from this guy. Maybe this is the VPod router 192. I don't know why you have this IP. It's a PIPA, right? From Microsoft. Then you have another connected route, which is configured on the DL on this device. And you have this three devices or this three subnets that I learned from BGP. If you'll notice, right, these are the subnets that is being represented by the web app and DB VMs, where the gateway is configured on the DLR itself with the sub interface, right? So these are the subnets. And the DLR advertises it to the ESG. That's what it means. That's why from the routing table, we can see that if I want to go to this VMs, I just need to forward it to the DLR, which has this IP address from the peering 172.16.0.10. And this is IBGP because it's showing an AD of 200. Okay, this is showing 20 because this is an external BGP learned from an external BGP peering, and this is IBGP, this is EBGP. All right, so if you know BGP well, you'll be able to understand why it's different numbers. Okay. Oh, yep. Yeah, it's here. It's actually, yeah. I haven't, as I'm told, I haven't seen it, right? But yeah, I explained the same thing because that's what I noticed. So, yep. All right. So that's the lab for on how to configure dynamic routing protocol between an ESG and between a distributed logical router. So the next one is about this one. I'm gonna do it another day because this is very, very long. So I'm gonna try this again later on, so I can upload this video so you can learn, so you can you can at least try this yourself, right, on how to establish BGP peering. Thank you very much. Bye bye.